We're going to try to find voltages in this circuit using nodal analysis, but we notice that we have a dependent source. This is a current source. Now step number one is we need to number the nodes, and we have node number 1, 2, 3, and node number 4. Step number 2, we need to select a reference point. In this case, this is going to be at node number 4. Then we need to assign voltages to each of the nodes, and we have voltage V sub 1 at node 1, V sub 2, and V sub 3 at node 3. And now we need to assign polarities, and we know that at the reference point we're going to have a negative sign and then positive for each of the voltages at the nodes. Then we need to determine how many equations we need to solve for the system, and we're going to then use our equation that will be the numbers of equations is equal to the numbers of dependent source on the circuit plus numbers of node minus 1. So we know that we only have one dependent source and we have 4 nodes, so it's going to be numbers of equations equal to 1 plus 4 minus 1, and that's going to be equal to 4 equations that we need to solve this circuit. We're going to write our first equation at node number 1. We write that Kirchhoff's current law is equal to summation of current going in equal to summation of current going out. Then I sub d, the dependent current, is equal to 2 I sub 3. I sub d is also b sub 3 divided by 2. Then I sub d will be just equal to b sub 3. Then currents going in are 4 amps plus the dependent current source, I sub d, and currents going out is b sub 1 divided by 2. And the current going from b sub 1 to b sub 3, so b sub 1 minus b sub 3 divided by 2. And then we write 4 amps plus b sub 3 equal to b sub 1 divided by 2 plus b sub 1 minus b sub 3 divided by 2. That is equal to, sending 2 to the other side, 2 times 4 plus 2 b sub 3 equal to b sub 1 plus b sub 1 minus b sub 3. If we continue, that's going to be equal to 8 equal to 2 b sub 1 minus b sub 3 minus 2 b sub 3, and that's going to be equal to 8 equal to 2 b sub 1 plus 0 b sub 2 minus b sub 3, and this is our equation number 1. Now we're going to find the second equation at node number 2, and then we write Kirchhoff's current law, stating that the current going in is equal to the summation of current going out. And so the first equation is no currents going in, so is 0 equal to I sub d, this goes out, plus b sub 2 divided by 2 plus b sub 2 minus b sub 3 divided by 2. Then we have that I sub d is equal to b sub 3, so we can rewrite 0 is equal to b sub 3 plus b sub 2 divided by 2 plus b sub 2 divided by 2 minus b sub 3 divided by 2. Multiplying 2 on the other side, that's 2 times 0, and then we have 2 b sub 3 plus b sub 2 plus b sub 2 minus b sub 3, that is going to be equal to 0, equal to 0 b sub 1 plus 2 b sub 2 plus 1 b sub 3, and this is equation number 2. Now we're going to find equation number 3 at node number 3. We state that the Kirchhoff's current law is that summation of current going in is going to be equal to the summation of current going out. Since we don't have any currents going in, this is going to be 0, and then the first current going out is b sub 3 minus b sub 1 divided by 2, second current going out is b sub 3 minus b sub 2 divided by 2, and then current b sub 3 divided by 2. Multiplying 2 on the other side, leave us with b sub 3 minus b sub 1 plus b sub 3 minus b sub 2 plus b sub 3. Rearranging, we have 0 is equal to minus b sub 1 minus b sub 2 plus 3 b sub 3, and this is our equation number 3. Let's rewrite the equations that we found at node number 1, 2, and 3. From node 1, we have the following equation: 2b sub 1 plus 0b sub 2 minus 3b sub 3 equal 8. From node 2, we have that 0b sub 1 plus 2v sub 2 plus 1b sub 3 equals 0. And from node 3, we have that minus b sub 1 minus b sub 2 plus 3b sub 3 equals 0. In matrix form, we can rearrange, and this is going to be 2, 0, minus 3, 0, 2, 3, minus 1, 3 for the coefficient matrix, and then the vector b1, b2, b3 equal to the resultant vector 8, 0, 0. This will give us a result of the general determinant equal 8, the determinant 1 equal 8 times 7, determinant 2 equal to minus 8, and determinant 3 equal to 16. Then the voltage is b sub 1 is determinant 1 divided by general determinant equals 7 volts. B sub 2, determinant 2 divided by general determinant minus 1 volt, and B sub 3 is determinant 3 divided by general determinant equal 2 volts. So the voltages at our circuit are 7 volts for B sub 1, minus 1 volt for B sub 2, and 2 volts for B sub 3.